Very good morning, students. So this is Dr. Eustace Russell, working as assistant professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Robot Dynamics and Control. Under that, in the last class, we have started with the Unit 3, that is Robot Control System. We have started the few basic introduction topics we have covered. That is basic introduction of manipulators, why manipulator is needed, and sensors, the basic types you have seen, as well as we started with actuators in the last class. The basic definition and basic classification we have started in the last class. Today we are going to see in a detailed manner of those things. So in the upcoming slide we will see one by one. So again, the glimpse of the syllabus. We have already discussed about the syllabus in the last lecture videos. Then today we are going to see about the stepper motor. When incremental rotary motion is required in a robot, it is possible to use stepper motor. So when the incremental rotary motion, some of the step-by-step rotary motion is needed, then we are using the stepper motor. Stepper motor possesses the ability to move a specified number of revolutions or fraction of a revolution in order to achieve a fixed or consistent angular movement. I will repeat once again. The stepper motor possesses the ability to move the specified number of revolutions or fraction of a revolution in order to achieve a fixed and consistent angular movement. This is achieved by increasing the number of poles on both rotor and stator. Additionally, soft magnetical material with many teeth on the rotor and the stator cheaply multiplies the number of poles. So this is the basic of stepper motor. So we have the poles such as rotor and stator, as well as magnetic field also, magnetic material also, many teeth on the rotor and the stator. Now this is the stepper motor, the glimpse of the stepper motor we can see here. The resolution, the number of steps per the number of steps per revolution of a stepper is determined by the number of poles in the stator and rotor. The relation between stepper motor relation and its step angle is given by n equal to a by 360 degree. N is the resolution and a is the step angle. So this is the formula we are using. N is equal to a by 360. Now applications. Stepper motors can be a good choice whenever controlled movement is required. They can be used to advantage in application where to need to control the rotation angle, speed and position, and synchronous. These include the printers, plotters, medical equipment, fax machines, automotive and specific equipment, etc. So main application where to need to control to rotational angle, speed and position. This type of motors will be included. Mostly the usage we have seen already. Servo motor. This is a glimpse of how the servo motor is performed with this. Now we will see the basic concept of this one. Servo motors are specially designed motors to be used in control application and robotics. They are used for precise position and speed control at high torque. So for precise position we have to prefer for servo motor, and speed control at higher torque also. Servo motor can be characterized according the motor controlled by the servo mechanism. If DC motor is controlled using servo mechanism, it is called as DC servo motor. Thus major types of servo motor may be as DC servo motor, AC servo motor. These are the two types of servo motors. Now we have the basic components. such as DC motor, potentiometer, gearbox, control circuit. Now we can see the diagram, the components with representing the various components. First is the left hand side, we can see DC motor, electrical input to an DC motor is also given, error detector amplifier, output shaft is there, potentiometer, reference output signal is also given over here. Now that motor giving the feedback to the motor, based on that it will be operating. Now then potentiometer, when the output shaft rotates, the potentiometer attached to it also rotate. Potentiometer are actually voltage dividers. So output voltage of potentiometer at amplifier changes with rotation of output shaft. This the feedback voltage, which depends on angle or the position of output shaft. This motor allows precise control of speed and position. To set the desired output, a DC reference voltage is determined using a potentiometer, pulse converter or timers. In digital control, microprocessor generate PWM pulses for accuracy. Feedback obtained through a potentiometer guides an error amplifier, ensuring precise motor positioning. The amplifier compare current and desired positions, generating an error voltage that powers the motor until the error is zero, facilitating accurate rotation. Servo motor are commonly controlled using a method called pulse width modulation, that is PWM. That is called pulse width modulation. This technique requires the transmission of an electrical signal containing pulses of different length to the motor. These pulses have a width that varies between 1 to 2 milliseconds, and they are sent repeatedly at a rate of 50 times per second to the servo motor. The adjustment of the pulses width serves as a means to effectively control the position of the rotating shaft in the servo motor. Please go through this point once again. The adjustment of the pulse width serves as a means to effectively control position of the rotating shaft in the servo motor. In simpler terms, changing the duration of this pulsar guides the motor in achieving shaft. So that pulses we are going to, that is I already told, the PWM, that is called pulse width modulation. Based on the modulation of the pulse, we can change the duration. We can achieve the which guides the motor. Wherever change the position of the rotating shaft in a servo motor also, the rotating shaft position can be maintained. The position can be maintained by adjusting the pulses. Then the types of servo motor first is based on the rotation. You will see that is first is the positional rotation servo motor. These servos can rotate the shaft in approximately half of the circle, that is 180 degree. It also frames a function that prevents rotational sensor from over rotating. Positional servos are widely utilized in limbs, robotic arms, and a variety of other applications. Then continuous rotation servo motor. They are built similarly to position servos. However, it can move in both clockwise and anti-clockwise. It can rotate in both directions, right? Radar systems and robotics both employ these types of servos. So radar systems and robotics both employ these type of servos. Linear servo motor. Similar to positional servos, linear servos use additional gears to switch between circular and back and forth output. Circular as well as back and forth, the front and forth. These servos are utilized in high-end model airplanes. Now, based on the characteristics, we can characterize this the various terms, that is control principle, accuracy, feedback mechanism, cost, complexity, speed variation, torque at lower speeds, then application. Control principle means it will be a servo motor means it will be coming under a closed loop system. Stepper means open loop system. Accuracy, higher accuracy due to feedback, and closed loop. Based on the feedback, we can do the changes, whatever it may be. So that is coming under closed loop system. Lower accuracy compared to servo motors only. Then feedback, provided with feedback devices for continuous position monitoring, typically absences feedback. Then cost, then more expensive. Cost is more expensive, generally more economical. Complexity, more complex control system due to closed loop feedback, similar control system. Then speed variation, capable of higher speed and dynamic adjustments, generally operates at lower speeds. Torque at lower speed also, good torque at lower speed. Whenever the torque is more, the speed will be less. Whenever the torque is high, then speed will be low. Then application, preferred for application requiring high precision. For high precision means because it is a closed loop system, based on the feedback it will get operated, and accurate position control such as robotics and CNC machines. In stepper motor offer used in application with less demanding precision and speed requirements. So these are all characteristics of the servo motor and stepper motor. So these are the references which I took for preparing this content. Kindly go through these references. So thank you, students. Thank you for your kind attention. So we'll completed first two parts in unit 3. So we will see in the upcoming videos of part 3 and part 4. Kindly subscribe this channel, share this video to your friends. So we will see in the upcoming videos. So thank you, students.